Welcome to the second lesson, AI alternatives. The idea for this section is to make sure you understand the menu of possibilities when it comes to AI. And the reason I put this early is because if you don't understand that there's alternatives, ways to do AI, it's hard to be able to reframe a problem or rethink it. So this is why making sure people knew about what are the possibilities of this comes into play. So this is part of the loop. The next lesson is going to go through the loop and the entire process of thinking through and how to reframe something. But before we can reframe something, I want you to all be aware of that there's lots of possibilities. Now, I understand some of you have experienced, you've kind of gone through this before, but I think it's an important component of this course to kind of include this information to make sure everybody knows it. Now, the reason I'm doing this is because this is information that, yes, you can use ChatGPT to learn all about forecasting and all about these different techniques. But the ChatGPT never knows everything about your particular situation. It doesn't know about the nuances of your data. Who's on your team? What are your requirements inside your enterprise? Right? What's your resources for your engineering team? What the prior history of analytics is. And often those considerations come in to play. So yes, ChatGPT is a great tool to help you do this. My thinking here is to give you enough knowledge so you can think about alternative possibilities, but then go use ChatGPT, go use Claude, go use another tool to do the deeper research on this. But if you're not even thinking it off the top of your head, you're not going to be able to otherwise do that. So that's a big piece there. Now, kind of in putting together this lesson, one of the things I ran across was a story about Sony. And in Sony, when they had engineers, the engineers that were in the R&D department, right, thinking about new innovations, new ways to solve them, they would only stay in that department for 2 years. Sony would rotate engineers all the way throughout their company because they understood that the way to build engineering and the way to build the knowledge to understand all the different ways you can build something is by having a rounded understanding of all the different parts of a company like that. And I think this is a good strategy to reflect on. It's something we often kind of hyper specialize and kind of force people down very narrow roads, especially in technical disciplines. But I think one of the pieces is having that general knowledge, understanding how different components fit together. You're not going to be an expert in everything, but still having a sense of that is very good. And this is something as for you, those of you who lead teams, it's very good to kind of force people to rotate a little bit, to see some other parts, explore some other parts, just so they're aware of it. They might not specialize in it in the long term, but just to gain a little bit more familiarity with it. The other quote I want to use here is it's attributed to Albert Einstein. Right? If he only had 1 hour to save the world, you'd spend 55 minutes defining the problem and only 5 doing the solution. And looking this up, it doesn't actually look like Albert Einstein actually said this, but I think the whole question stands for itself, and I've seen it in many contexts, and it's widely agreed, and it's just a reminder for that kind of spending time to do thorough planning up front really pays off for doing a solution. We see this all the time now with agentic AI and AI that can write code and code. You still have to come up with a good plan up front, because if not, the thing's going to code away and get lost along the way. And so again, I want to put the emphasis here on thinking things through, on the importance of planning, because when it comes to different AI, there's a whole set of AI tools and possibilities that are out there, right? I shoved a bunch of different concepts on this chart, and it doesn't even have half the stuff on it, right? There's lots more AI pieces. So I'm not going to be able to give you all of AI pieces here, but I think it's important to have a general knowledge of what are the main areas, how are different problems being solved, and it's something, as we'll talk about at the end, something that all of us have to continually learn if you're in the AI field. It's a field that's ever evolving, and so it's important that your knowledge is always constantly kind of being refreshed and up to date on this. And so this is where I want to make sure all of you understand some of the menus here. Now, the way I'm doing this video, I'm going to dive into many of these different topics here, but I don't want you to just sit and watch this video end to end at once and that's it. I think what's going to be most valuable is you'll watch parts of it and then come back later, watch some more parts of it, the ones that are applicable to you. I don't think having this video all in one sitting is going to work, because the idea here is I'm throwing a lot of knowledge in this one about how AI works, and it's kind of hard to take that all in. And this is to help sharpen your thinking around AI, because we want you to be able to think about problems and consider different lenses, different perspectives on doing it, and why you might kind of need to reframe it. And so that's a lot of what I want to get out of this. And, if you go and look at other areas, it's quite common. If I go and I say, hey, I want to grow my sales and business, well, you know what? There's many different strategies, and people will walk down like, hey, what are you focused on? Are you focused on transactions? Are you focused on increasing traffic? Well, then I have a couple of different strategies that fit that particular way of doing things. AI is the same way. But I want everybody to be flexible, to understand there's lots of AI tools, approaches, methodologies, techniques out there that are appropriate for kind of different solutions. And it behooves us all to kind of be educated generally about all of this. So kind of, I don't want you to kind of go through this, memorize all this, but you should have a sense of what is the map of all the stuff, because again, like a lot of these decisions, you're going to be making very quickly. You have stakeholders in the room. You're going to be talking about it. You're not going to have time to deeply always think. So at least being on the surface of knowing these alternatives, being able to get that right framing out there early on is very useful to you. Now, the first piece I want to talk about is we always talk about AI and AI's, but you don't always have to use AI. Sometimes, for many problems, a simpler solution might work. For example, here you can see we can go kind of line by line through this, where I could go out and get a huge machine learning neural network model to build predictions, but you know what? Maybe all I need is a hard-coded rule that says, if the amount of the order is above 10K, then require approval. Now, you could see how some data scientists could go build a huge machine learning model that takes many different columns and put a lot of complexity around it. But you don't always need that complexity. Sometimes hard-coded rules work. Or if you're doing forecasting, maybe just using what happened last week, what happened yesterday, what happened last quarter, use that as a baseline, as a simple rule. In anomaly detection, let's just look at the data, figure out what is that 95% threshold or 99% threshold. Let's just flag that. Use that as a way. These are very simple baseline techniques that often we can avoid using AI. And it's not just traditional ML. For those of us working with LLMs that are extracting information, for example, good old-fashioned regex, right? You can use this to extract lots of complicated information that way, or use templates if you're trying to go generate information, kind of like Mad Libs. Doesn't work for every scenario like that, but you should always kind of have these alternatives just before you kind of instantly jump to AI like that. And even if you're going to use AI, having these as a baseline to be able to judge how much better is your AI solution than just a simple baseline is really important when you start thinking about how much you're investing into the AI solution in terms of developing it, keeping it up, maintaining it like that versus a rule. Now, once we're kind of in the AI, I saw this quote and I just had to throw it in there, that, right? Lots of people want advanced AI ML, but really only need linear regression. So now this is going to go in deeper. As I was setting up these courses, these things all just kind of came to mind, were top of the head in terms of what kind of an AI engineer, a data scientist needs in the beginning of 2026. You should be familiar with all these concepts, know when to use each appropriately. So this is when it's going to get a little longer. I'm going to start going through all of these like this. And again, don't try to take this all at once. I've tried to make the slides pretty dense that cover a lot of different pieces of information, from defining the problem to giving you example use cases to helping you contrast the different frames as well. So use those as well. I'm going to try to make this a little bit more fun. I'll try to add my own stories in here as we go through this. So feel free to fast forward if you need to. So one of the traditional things that happens is people are like, should I use forecasting or regression? Or maybe they're using a regression and they're like, maybe we need to reframe this as forecasting. And the critical piece here is does the order of the data matter? Because when you're working with regression, you're really trying to predict what that Y value is, such as, what is the value of a house? While forecasting are the types of problems when you're trying to predict what comes next. So that helps us decide kind of which one is better. Sometimes you can use both for some problems. Now, Amazon, for example, uses forecasting for inventory management, figuring out what are the stockouts, what does them demand, knowing that is useful. Staffing and operations are often common forecasting use cases as well, for figuring out how to schedule staff. Right? The prices, the Uber price that you have, that again, there could be a forecasting model that does that. And that's because those things are looking at what comes next. When you're trying to kind of decide, should I use a regression? Should I use forecasting? I've built these visualizations to kind of help you go better. I'm going to quickly go through this. For those of you who need to understand this a little better, go ahead and just read it a little bit more carefully. But if you're, for example, worried about what's going to happen next, what is the goal next week, a year from now, that could be more likely a forecasting model. Doesn't necessarily have to be, but kind of leans towards that. Or if you're dependent on something that happens in the past, right? Like what happened yesterday is affecting today. Well, that could be a little bit more of a forecasting one. Another one is the missing input data. If you want to run a regression, but you don't actually know what the value is, maybe then at that point you're actually doing forecasting. And finally, how you're evaluating this. The data, is this something that you can randomly split? If you randomly split, you end up cheating? Well, in that case, probably the sequence of data is important. And so you are having to set your problem up as a time series or forecasting. And look, there's many nuances to this. My idea, again, is understanding, even though you're trying to predict something, it might not be a regression problem. It actually could be a forecasting problem. Let's talk about this, some other contexts as well. Two other common things are, should I do classification? Now, classification, you're separating things into groups, such as I want to predict where this email goes to. Does it go to accounting? Does it go to HR? Does it go to operations? That would be a classification. Now, a similar type of thing that you could reframe that is anomaly detection, where you're looking for something unusual. I want to find the emails that don't fall into those buckets, for example. And anomaly detection comes into play in many cases. For example, for fraud, you might be looking for new patterns, things that haven't happened before. Anomaly detection is a very often popular use case. This is one where talking about the business value is often important, but you can see through the examples here, Toyota uses this for machinery failure. CrowdStrike uses anomaly detection for cybersecurity. So you might kind of initially see some groups at the beginning and think classification, or maybe you're like, hey, I'm going to do an anomaly detection at the beginning, but then I want you to think there could be times where you might want to kind of reframe this, and some of the signs that you might want kind of anomaly detection versus classification. If you're looking for unknowns, like what good looks like, but bad can look like many other things, right? You can't put them in narrow kind of class categories. That could be anomaly detection. If it's a needle in the haystack, right? If there's only a few examples like that where you don't have enough signal to actually create a class of that, that could be much more of an anomaly detection. if it's something that's changing over time, what happened a month ago is different than what happens now. This is that new trick problem. Maybe then you're better off trying to use an anomaly detection method and those techniques and algorithms that are suited for that as well. Or perhaps kind of your data has things that you've never seen before, right? That your classification works if you have training data and test data. If not, maybe anomaly detection works better. Now, I've seen anomaly detection and classification used both widely. Another potential reframing is whether you should be using clustering or should you be using classification. And a lot of this comes down to, in general, is are you defining the groups because you know exactly what you want, classification, or do you want to just see what comes out of the data, which is more clustering, kind of that data-defined way to do it. Now, clustering is used in lots of techniques. It has very useful pieces of it. For example, Spotify uses it to cluster all the different types of music. Let's see, what are the groups? What are the genres that people are listening to, and let it come from the ground up by the people. We have other cases here. You can see Nike's used it for kind of clothing sizes. Target uses it for identifying shopper personas. So you can see there's a reason that you might want to learn from that data versus other times you might want to go ahead and put your classes on there because maybe you're running an advertising campaign and you already have buckets of people that are in specific demographics, and that's how you're targeting. And so allowing it to come from the bottom up isn't very helpful at all like that. So again, here are some signs that you might want to kind of use clustering instead of classification is if you don't have labels, right? You need labels for classifications, or if you don't trust the labels that you have. The cold start is another phenomenon where, again, you're starting again, where maybe you'll use some clustering to give you those initial labels. And sometimes what happens is you bootstrap that initial labels from your clustering and turn that into a classification. And then you can go from a classification from there. Or things are shifting fluidly, kind of that fourth bucket here. Again, then you might want to think about kind of clustering as well. Another overlooked area is recommendation in machine learning systems versus prediction. And this comes out to, like, are you looking for a score or rank of somebody? Because sometimes it feels interchangeable, but this is where you need to think, how is it being used? Are we really using it to rank people or to rank goods, for example? Like TikTok uses this to rank videos. Amazon uses it to help us recommend goods, right? Google uses it for search results like that. Recommendation is actually a very common task, and it's one I often in the field that people don't see because you can sometimes model it simply as a prediction without taking it into account. And so what you want to do is sometimes it's useful to just go ahead and predict how many stars a show might have, for example, like a scoring system. But other times you might want to give people a list saying, hey, here's your rank list 1, 2, and 3 of what movies that I think you'll like. So if I'm a little quick here, take a second to reflect and make sure you kind of understand the difference between the two, because there's two different ways of looking at the problems here. And one of the reasons you might want to go to kind of recommenders is maybe that scale isn't useless. You know, that 3 stars is better than the 5 stars. One of the pieces is you'll see that lots of times nowadays we don't use as many scales, 1 to 5, 1 to 10, because we found out that it's not that effective at all because it's hard to get users to give that kind of very granular signal. Sparsity's another issue here. If you're trying to make a prediction and you just don't have a lot of data, it gets very hard. So that recommendation where you can use other information can be helpful. Let's see, we've got this choice paralysis where it predicts everything is 5 stars. Well, then that's not so good, right? You need to rank. You need some way of identifying what's best for a user like that. Or best depends on what's next to it, the context of that as well. So all good lessons. And this is one area that if you're not familiar with recommendation, I'd urge you to spend a few minutes, make sure you understand when you want to use it. Another area that's often overlooked is optimization. Oftentimes we'll just build models where we can make a prediction of a number, but sometimes what you're really trying to do is optimize. You're trying to kind of use all this information to make a best of decision. So some common use cases for optimization, for example, is logistics, where you have to drive road paths, right? You want to drive the shortest, the most efficient path. And even then, I think, and hopefully we'll have an example here, even then, the shortest path can be very different. It might not always be the shortest path in terms of distance. It could be, for example, with UPS, the shortest path without left turns, because they know left turns cost a ton of time like that. So, optimization can be factored in many different ways like that. If you're doing ad bidding, right? Facebook auctions, if you're running across auctions and you only have so much money, or for you fantasy football players out there, right? If you're in a league where you have to pay for players, you only have so much money. How can you optimize that money for best doing those? Scheduling as well. You want to figure out how can we give the best possible schedule to everybody that works there. These are often questions where we want to use some type of optimization algorithms and not just rely on predictions. So I've got here some of the signs for why you might need optimization. It could be if your goals are conflicting. This is a real thing of we have to start trading off it. Optimization comes into play. It's all about kind of working within those constraints like that. If you have conflicting goals, right? If you only have so many resources for doing that, if, like with the UPS example, there's lots and lots of options, prediction can just be too big like that. So it makes sense to use some optimization to constrain the space like that. Optimization is very useful for kind of creating the plan, giving us an action to do that as well. And again, I think it's very undervalued in terms of the toolkits most organizations are using when approaching problems. Now I want to switch gears a little bit away from traditional machine learning, and I want you to compare traditional NLP, natural language processing, versus LLMs. And this is something I see every day. It's really a gap that's been starting to happen since we've introduced LLMs, where we had traditional NLP that was really good at building patterns, where we've looked for patterns, heuristics inside of language. Now we have LLMs that are trained on, huge amounts of information that can almost reason through text in a much better way. But even with LLMs, there can be many times where you might want to use traditional NLP. And again, like the idea here is just giving you flexibility in your mind for thinking about it. Something like PII redaction, right? Where it's fairly standard kind of numbers like that. And you have lots and lots of information to get through, right? Traditional NLP is going to be a little bit cheaper and faster for doing that. Anything when it comes to lots and lots of data, like spam filtering for Gmail would be another one. LLMs are very heavy. Taking it, those models have a lot more compute around it as well. Maybe you're doing something simple like sentiment. Traditional NLP is good at sentiment. You can go to an LLM and get a little bit better, but again, at that cost of all of that compute. So for some tasks, kind of right now, I have this nice here quote, like using an LLM for every small NLP task is like bringing an earth mover to plant a seedling. And that's the way you got to think about it sometimes. And so this is where you have to, as you're scoping out the problem, we'll talk about this more, right? Like what are the resources you have? Does it make sense to kind of just go for something simpler like that? So again, right? Like if it's something that you can do in regex, if you have huge amounts of data, and I haven't talked about this yet, if you need an audit trail, right? Some determinism, right? LLMs can be, for the most part, indeterministic and cause some issues like that. As well as the response time. How long is this taking as well? I've seen many cases where NLP is used because it's much, much quicker like that. Another area of reframing that I often see is around generation versus retrieval. And this often comes into play when we're starting to think about generative AI. And if we're not very familiar with these tools, and people have to realize that there's a difference between when you're using a model to write some new information versus I want the model to write information, but based on my knowledge, based on my facts. And that's where retrieval comes into play with this. And we'll often talk about retrieval augmented generation as well. And so this is where you have to get a sense of like, is this generation something like marketing copy where you're just generating lots of variations? It doesn't have to have a link to something factual. Or on the other hand, are you doing something that's much more factual where you have to retrieve the exact paragraph from the help docs? Well, that leans you towards retrieval as well. If you're doing legal discovery, relativity, right, you might have to look and find the relevant email. You need that exact email without altering a single word of that. You want to be able to retrieve that. You don't want to count on a model to generate it because it could easily hallucinate and get something wrong in that way. So some of the reasons you might think about like a RAG, a retrieval type of solution is the cost of a mistake? Is the cost of a hallucination going to be significant? What about time? Is it something that changes over time? Because models have been trained on previous data. They get locked into that. They can't keep up to date with time, while retrieval can grab us the newest and latest information as well. Is there something with privacy? Information we don't want to give an LLM, don't want to give an API. Again, a retrieval strategy might be better. Or if you need receipts, you need that trail of exactly how you got to that document, you want to use a retrieval, a grounding signal as well. Now, another common use case now in Gen AI is extraction versus generation. And this is, when do I need to pull information, extract it out of my messy documents, maybe put it into something like a table, versus when should I just use an LLM to go ahead and generate some information, right? Just use ChatGPT to do something. Now, extraction often comes into play when you're dealing with lots of unstructured information. You want a few fields out of it. So invoice processing is a great one, right? I'm always just looking for the vendor, always just looking for the dates. Maybe I'm working with clinical notes, and again, these are the specific areas that I'm looking for. That makes it much easier to kind of do extraction as well. Code documentation as well. So some of the reasons that you might, as you're kind of framing out problems and like, what things are, some things to kind of set a bell in your head is if you have a schema, right? A schema is very much attracted to extraction, related to extraction, if you know exactly how you want your data out. If it's something like you could just literally like highlight the information in, that's probably more of an extraction job than I'm generating and writing a story, kind of a generation thing. If you're using this extraction to drive another process, well, that's probably an extraction as well. And finally, if you only care about a little bit of information within the larger documents, well, extraction is going to be much better than in that case as well. All right. Another one that comes up is the different ways we can search for information nowadays. So here I'm going to compare semantic versus lexical versus a structured search. So lexical is our traditional word search, right? We match the words exactly like that. Semantic is where we've grown with LLMs and the idea that we have these models that understand language and can find related concepts, things that are semantically related, sneaker and tennis shoes, for example, and knows that those things are similar to each other, like that car, automobile. While structured search here really is the text to SQL that we see widely being used to, I want to search a database. I want to search my Snowflake or Databricks database. I want to find out what was the top revenue for over the 6 quarters. That would be kind of a structured search. Hopefully you keep all three of those in your mind. It's really important to tell the difference and know when to do each of those. Something like a part catalog, where you have the exact number, the exact name, is better for lexical because you don't want the concept of that part. You want that literal part number like that. While if you're doing something like an employee wiki, well, people aren't going to know the exact terms that are in the HR document. So having a little bit of semantic flexibility there is useful. On the other hand, if you're like, hey, I need to find all the deals closed in Q3, that's going to want to search a database. The best way to search a database is to be able to use SQL as a tool to find that information and pull that out like that. So a structured search through that. So some techniques you can kind of use to figure out, is it something like a barcode where you need lexical? Or is it something like a price tag test where you're doing something with a quantity or a date that maybe leans towards more of a structured search? Is it something that your users are probably not going to say exactly like they have it on their tip of their tongue? Well, then you could be using kind of a semantic approach like that, or if they're going to be asking kind of general questions, again, a semantic approach. But I want you to have these in mind whenever search comes up. Being flexible, understanding these different approaches is really important nowadays. Another common framing is, should I be using fine-tuning or should I be prompting my model? And prompting models is giving it instructions. It's adding to the context, having the model do something with some new instructions. While fine-tuning is literally changing the weights. You're changing the structure of the model. It's a much more heavyweight work. It takes a lot more resources to do the fine-tuning like that. There's trade-offs of each. I don't expect you to understand all the nuances of the difference between that. I just want you to understand that when we're working with models, we have different ways of affecting them. One is by the instructions that we give through prompting. The other is through fine-tuning, through changing those weights like that. Some examples of kind of where fine-tuning a model instead of prompting has come into play. For the most part, 99% of the time, we're doing prompting. So just if people are thinking this is a 50-50, it isn't. But some of the cases, the rare cases of fine-tuning, is you could see Coca-Cola's used it to get a model to speak in a specific tone of voice. Bloomberg's used it for, I want a specific output kind, a JSON schema kind of output like that. Zendesk, right, as uses prompting with RAG to update shipping policies. So some reasons that you need prompting, and again, fine-tuning. And again, fine-tuning is a little bit rare, but is this something where you're doing so much prompting, so many things that it makes sense if we can almost literally embed those prompts in the model, even though you have that upfront cost? Is there something where we want to get that tone right? It's too hard to prompt it to get the tone. We just want to give it lots of examples and fine-tune it. Or is our prompt getting so long, right? The complexity of it that maybe if we can fine-tune it and just embed that knowledge in there like that. Or is there some new skill that our model really lacks? And we think if we give it enough fine-tuning examples where we can kind of change the weights more so than prompting, that it's going to be able to pick up that new skill like that. All right. Another one common in the AI space now is long context versus RAG. And I see this debate on Twitter and X all the time like that. So we have these models that can hold more and more information. So kind of when the BERT models, for example, first came out, their context length was something like 4,096 characters. We could think of it as that. 4,000 is a little bit, but it's not a lot. Nowadays, most models are in the area of 200,000 characters, and that, or 200,000 tokens, and that's a pretty good amount of information. However, you see some models, Google has a 1 million that's available. I think the latest Anthropic models are 1 million. Google supposedly has a 10 million. Now, when you get to 10 million, you can hold literally hundreds of books inside that 10 million context. And when you can just shove that many books, people are like, well, why would I go through this RAG approach? Because what RAG does is it goes and it takes all the different contexts we have and chunks it up into smaller pieces. You just search and find the piece that you need and use that. When it's that magnet that you use the magnet there to find the needle in the haystack, you find the chunk of information that you need with RAG. Now, the reality is that even as long context models get bigger and bigger, they're never going to be able to have all the context inside an enterprise that has thousands, millions of pages of documents like that. The other thing is, as you shove more and more information, these models, they lose track of a little bit. It also costs you a ton of compute. It's more efficient to just give the model the context it actually needs to answer the question and not fill it with a lot of junk. Nevertheless, there's always a debate. It's good to understand kind of the nuances of either of these like that. Sometimes, for example, if you have a 50-page document, having a long context is great. I want to be able to summarize all the risks. I don't want it chopped down into pieces. What else do I have? Podcast notes, right? I have a 2-hour transcript. I want to find themes. Well, maybe if I want to find themes, that RAG approach of breaking it up makes a bit more sense like that. Or if I just need to find one specific error code solution in a 10,000 page manual, well, you could put it all in long context and ask for it, right? But you're putting all of that stuff, if it's even possible, into a model versus maybe I just chunk it, use my good old-fashioned lexical search, find that one chunk that has that information and just return that. I can save a ton of LLM resources that way. Okay, so here's some of the signs whether you need kind of long context models. That global summary, great one. If you're doing summarization of long of documents, yes, the long context works instead of breaking it up into chunks. If you're trying to connect two different pieces of information together, having them in the long context matters as well. For some things, there's the bad chunks problem here. If you're working with really large, messy tables like that, where when you create those chunks, they're not going to be accurate. Could be another one like this. Or the vibe search. If you're looking for kind of semantically related information, maybe it's easier to use it all in the long context like that because it can kind of read the entire piece. All right, the last one I want to add here, and I just am kind of adding these last couple ones because literally kind of in the last month or two, these things have become much more of an issue, is when should I use like a workflow or a pipeline where I have specific tasks, I hard code that literally, versus when should I just use one of these new autonomous agents, right? Things that have reasoning that can work by themselves like that. And when we do this in lecture, I'll share some of the numbers of the different costs and performance of that. But this is a real dilemma right now that if you're building AI engineering problems right now, this is forefront on the folks doing agents, is when does it make sense to use a step-by-step process of a pipeline versus when should I have an agent just kind of think through things to do. Now, again, like I'm not going to give you, there's no straight answer I can give you for this. It's something to consider both possibilities and see what works for yours. There's reasons for each of these. If you're doing a loan approval pipeline where you already have steps in your organization of checks, well, probably using a pipeline to replicate that where you have complete transparency and you're kind of mimicking what you already do makes a lot of sense to do that. On the other hand, if you're building a coding assistant and its goal is to get from code from A to B and you have ways to check it along the way, just go send it off, let it work. Like there's no reason not to kind of just use an autonomous approach like that. And so I've got some signs here to help you think through kind of, is it an if else, do you know what tools you need or is it better left for the model to figure out what tool to do? Is it something that the models can self-correct and figure out for themselves? I mean, how much of this problem can you decompose, or is the problem slightly different every time? So it's easier then to use a reasoning model as well. And, these things are always going to continue. I can't keep you up to date on everything. I think one of the pieces now is, do I reframe as a single agent, or should I use multiple agents? And again, in class, I can kind of share some numbers and some trade-offs of that. But again, the idea here is just for you mentally to just be aware of, there's many ways to solve a lot of these AI problems that we deal with. Having some sense of the different alternatives is very important for you. Now, here's a quick summary of kind of the different techniques I've quickly ran through here as well. I thought it's hard to talk for a long time just in front of this by myself to this, but happy to answer questions on any of these methods as we go through this, whether it's in the internal class chat or in the sessions as well. But this, hopefully at this point now, I've given you a bit more flexible mind, and you're starting to see like there's a lot of techniques, there's a lot of approaches. You should be like feel like a little overwhelmed by like all the different ways you can use AI, and like your mind should be bobbling a little bit. And here's the thing. I want you to spend time making sure you take some time to keep expanding this mindset, especially the way AI is going now with being able to code and do everything. Having your mind open, knowing the general nature of things, because you're going to be managing these agents, you're going to be managing the outcomes of these. So having that, some of the things I do, and I'm suggesting for all of you, of course, to do is to ways to expand that mindset. Do a lot of diverse reading. Don't just focus in one area at one technical depth. Lots of different pieces. One of the ways I do this is I have a lot of different newsletters I subscribe to. I find that's a little bit of the highest quality information that I'm getting is through newsletters nowadays. Do varied projects, especially for folks that have less experience. The best way to understand one of these techniques that I've talked about is spending a little bit of time building a project in it. And that'll help kind of burn it into your soul. So you're never going to just learn, especially in this technical profession, everything just by reading, by watching these videos. You have to spend time doing it, because that's how it's going to really get ingrained inside you, where you really feel in your soul what are the trade-offs of these pieces. There's also some nice engineering blogs where some companies share exactly kind of the nuances of the hearts, the issues they had kind of implementing this stuff. I'll share some of those as well. Spend some time, like Sony, the cross-functional exposure. Try to see if you can work on maybe one project out of the 3 or 4 you do, where you can work with a little bit different teams like that, just to kind of expose yourself to build a more general, a more robust mindset as well. And then finally, we're going to spend time on kind of reframing here, but I want you to now, as you start looking at things, as working on projects, just ask people, what are other ways they could have solved it? What were the critical decisions for why they started down one route but then ended up in another way? Learning all those examples like that will just further help your own development like that. Now, in terms of resources, I threw together a quick document on some different diverse news sources like that. There's plenty out there. You can find your own. I will share kind of a starting point for you for all of that. But I think this is part of that continuing education that all of you should strive to do around this, like this. All right. Thanks again for kind of sitting with me through this. Hopefully, we've kind of opened your mind to lots of AI alternatives. Looking forward to kind of any questions or comments or feedback that you have. Thank you again for taking the time.